Professor Rhodes is an advisor on low carbon energy to the European Commission and director of Freshlands Environmental Actions. He's based out of Reading. He's also a board member of Scientists Warning Europe and the co-author of the new World Scientists Warning into Action from Local to Global paper. And I will hand it over to Professor Rhodes for his presentation now. Enjoy.
Okay, thank you, Padma. Yes, energy in the changing climate. Well, let's look at our overall use of energy by source. You can see the big guys on the left-hand side, oil, coal, and natural gas. Basically, these provide most of the world's energy, more than 80% of it. Then followed by nuclear and hydroelectric power. And I should say that actually this slide was drawn up about 10 years ago. And although we're using about 15% more energy now overall than we were then, the relative proportions haven't changed a great deal, except for the fact that coal is now down to about 27% from 30, and renewables probably about 5%. This is total energy, not electricity. So basically you can say that coal has been substituted to some degree by renewables, but the black line there, the bar on the left-hand side, that's crude oil. And so crude oil has the lion's share of our energy, and it really is the lifeblood of civilization. And this you might call the good old days. This is the Humphreys-Jones giant gusher drilled out in Texas 100 years ago now. And it certainly did what it said on the tin, because at that time, all you needed to do basically was just drill down through the cap rock, and the pressure of gas and water in the ground would force the oil out in that familiar jet of black gold. And you needed, why do I say the good old days? Because you needed just about the energy contained in 1 barrel of oil equivalent to get out 50 barrels. So that's like investing £1, getting 50 pounds back. Pretty good investment. However, now the global average is below 20. For some of the heavy oils, it's below 5. So we're going to work much harder to maintain the overall flow of oil into civilization. So oil production, well, we produce about 30 billion barrels of oil every year. I can't imagine what 30 billion barrels of oil or 30 billion anything is, but it's obviously an astronomical quantity. It's about 82 million barrels a day, 1,000 barrels a second. So every second we get through about 1,000 barrels of oil. Amazing. Until about 10 years ago, the major producers of oil were Saudi Arabia and Russia, but the US joined this exclusive club due to the success of hydraulic fracturing, fracking, which now produces about 60% of America's domestic oil supply. And so these three nations produce between them probably a third of the total world oil supply. Oil comes as light or heavy, sweet or sour, depending on how easily flowing it is. The very heavier oils are like the black stuff on the road outside, and sour oils contain a lot of sulfur. The light sweet oil is best for making into petrol, easiest to refine, and there are large quantities throughout the Middle East and indeed in the United States as a result of producing very light oil through fracking shale. This is an exhibit in the Norwegian Museum of Science and Technology in Oslo. And as you turn that wheel, some of the very heavy oils basically stay at the end of the tube, whereas the others flow quite freely, like a sort of light cooking oil. And you don't need to drill that far apart to, in terms of the molecules contained, recover quite different samples of oil. So different kinds of oil are better for particular purposes. So the leading question is, how much oil is there remaining? Well, the fact is much of the oil left contains a lot of sulfur, is heavy, for example, from the Orinoco belt in Venezuela, needs more costly processing. And often you hear there are so many billion barrels of oil somewhere, but it can be that only a few percent will be recoverable. Extra heavy oil is not liquid, it's bitumen. So as I say, like the black stuff on the road outside, you often hear there's so many trillion barrels equivalent of oil in oil shale, more than Saudi Arabia. But actually, this is kerosene. And if you want to convert it into something like oil, you've got to heat it up to 500 degrees centigrade, and it takes a lot of energy. So there's a low energy return on investment. So oil, we use it for everything: fuels, transportation. It's also the raw carbon chemical feedstock for plastics, chemicals, everything, all our technology. We wouldn't be doing this without oil and related hydrocarbon liquids, because of the plastic materials that they are turned into. And without oil and natural gas for fertilizers, then modern industrialized agriculture wouldn't exist. And this is a bit of a poster child for the problems of industrialized agriculture. Obviously, you need oil to fuel the combine harvesters and tractors and so on. And also, of course, because food isn't consumed necessarily where it's grown, it's going to be transported around nations and around the entire world. And a poster child, because at one time this field of soybeans in Brazil was rainforest. And you can see this has been cleared. This happens rather a lot, actually, and not only for growing crops, but to graze cattle. But behind this mighty array of combine harvesters, that dust, this is the topsoil, because this is turned over by these very heavy, powerful machines. And because it's monoculture cropping, basically the land is left exposed to the elements, often when the erosive forces of wind and water are at their most powerful. So this land doesn't last for more than a few years, and then more forest is cleared, and so this destructive process continues. So supplies of cheaply and easily obtained oil are diminishing. Cheaply and easily obtained, I emphasize that. There'll be oil in the ground forever, but it won't necessarily be worthwhile producing it economically or technically. So at some point, we need to find alternative fuels and carbon feedstocks for industry. The other side, of course, is that burning oil contributes about 3 billion tons of carbon to the atmosphere. That's about 11 billion tons of carbon dioxide, which is about a third of all the carbon dioxide emitted by humans. And this is driving climate change. You can argue that obviously as the oil production wanes, then we'll be reducing our carbon emissions. But of course, because oil is so critical to this complex industrialized civilization we live in, maintaining the dynamics of that civilization would prove very challenging without enough oil. So what about alternatives? Well, this is a field of sugar beet growing in Norfolk. It grows very well up there. And so the name of the game is to get the sugar out, convert it by fermentation into ethanol, and this gives you about 5 tons of ethanol per hectare. But we've got limited amounts of arable land. And so we'd actually need, if we were going to replace all our petroleum-derived liquid fuels from bioethanol, then on that basis, even if we stop growing food crops, we could only produce a bit less than half our fuel requirement in the form of ethanol. And you often hear talk of cellulosic ethanol, say from elephant grass. This has the advantage you don't need to use fine cropland, you can use marginal land. But again, the yields are about the same. So it is limited how much substitution you can make in the form of bioethanol for the huge amounts of petroleum-derived fuels that we get through. Another aspect is the enzymes necessary for breaking down the cellulose and heavy cellulose into sugars for fermentation are expensive. And the point I'm trying to make is that compared with petroleum fuels, the possible obtainable quantities of bioethanol are rather limited. If you look at biodiesel, well, say from rapeseed, you don't get 5 tons of this per hectare, you get a ton. And just to sort of make it go further, if you were to convert all the vehicle engines over to diesel engines, because you get more miles per gallon, if you like, than spark ignition engines burning petrol, well, you'd still only overall be able to meet about 1/7 of our annual fuel requirement. So biodiesel is even worse from this point of view of substituting for petroleum. But also what's often not mentioned is that oil-based fuels are needed to grow and harvest all the biofuel crops, just like growing any other sorts of crops. And really it's debatable how much additional energy you get from the biofuels compared to how much fuel you had to put into the farm machinery in the first place. And of course, it takes a lot of fresh water to grow these crops. So it's far from ideal. Fracking, hear a lot about fracking from different perspectives, and it's extremely important actually because since 2005, 71% of all the growth in oil supply has come from fracking shale. And you're probably familiar with the process generally. This is the Marcellus shale, which contains gas. The shale is porous, so it contains gas or can contain oil, but it's a very low permeability, so the stuff can't flow out. So what you do is to put the well down, cement the piping in. This is horizontal drilling, and what's happened here is that basically the drill bit has been turned through about 90 degrees, so you can actually extend a long way laterally into the shale. Then what you have to do is to break the shale open. So a perforating gun is introduced, which has explosive charges, which blow holes through the pipe of the well and then into the shale. And then the fracking fluid is pumped down under very high pressure. That breaks the rock open. And once that's done, then the gas or the oil can escape, flow up to the top and be taken off to market. Now, this is very interesting. This is the overall production of liquids of all kinds, not just oil, but really everything. If you look at the purple line at the bottom, well, you can see, so 2000, from 2005, basically that flat line. So if you want to talk about that as regular oil, basically that could be regarded as peak oil. And it's only through the additional contribution from extracting heavy oil and also from breaking shale open that the global oil supply has managed to grow. And since the last 15 years or so, and if you look at the light blue line at the top, that's all liquid. That's natural gas liquid. Some of that has come out of shale. That's a proportion of that growth. So in all respects, we've really put a lot of our global oil production, any enlargement of it at least, in the shale basket. And in many ways, we're highly dependent on what happens to the fracking industry for maintaining the global oil supply. More about that subsequently. Now, the global oil price had been about $100 or so for about 3 years. And then it crashed toward the end of 2014. And what happened then was the market became oversupplied, in part through the success of fracking, which really is pouring quite large quantities of crude oil into world markets. And the point was, okay, this is $60, but at $100 a barrel, then all kinds of new production projects are viable. But at $60, they're not. So the fear here in this newspaper headline was that actually the oil companies wouldn't have enough spare cash to invest in new production. And because we're using up oil from existing fields, we've got to make up for that somehow with new production. And if that doesn't happen, well, obviously this is a threat to the oil supply a few years down the line. So this is a sort of overview of the global oil situation. I emphasize again, it's the cheap to produce oil, which is in decline. 81% of the world oil production is in decline by about 5% per year. That's about 3 million barrels a day per year. So to keep production flat, we've got to find the equivalent of a new Saudi Arabia's worth of production every 3 years, the equivalent of 3 new Saudis by 2030. So it's quite a dynamic process, really, recovering new oil to make up for production that is basically declining from existing fields. And on top of that, the new production has to come mainly from unconventional oil, like fracking, like extra heavy oil, drilling in deeper and deeper water. None of these are exactly cheap procedures. They're more challenging, more energy intensive, and more expensive. So production of these new kinds of oil in the future will mean that the age of cheap oil is behind us. It's also highly uncertain how much light tight oil got by fracking shale can be obtained, what the production rates might be from new fields across the world, or indeed if those production rates could be high enough to take up the slack, the fall in production from already producing fields. Oil demand is still rising, especially now post-COVID, which is why the oil price has rocketed recently. More about that in a minute. But until 2020, basically until the pandemic came along, and basically there were the lockdowns, factories and offices and all kinds of things were closing down. So there was a fall in demand for transportation fuels. Until that point, though, the market was oversupplied, and that pushed the price down. And as noted, when you have low oil prices, investment is also low. So over the next few years, we might expect there to be some issue over the maintaining the oil supply against demand. And this report was commissioned by the Finnish government, indeed just before COVID came upon us, oil from a critical raw material perspective. And they predict that there is likely to be a supply crunch probably during the last half of this decade. So it is an uncertain situation. And yeah, indeed, as if that uncertainty were not bad enough, along came COVID-19. There was a fall in demand for transportation fuels. Planes were grounded. As I say, factories and offices and all sorts of things weren't running as normal. And of course, the oil demand falls if the transportation fuel demand falls. So the price crashed. Trading January 2020 at about $60 a barrel, and then it fell at one point to about $13. The futures price actually went negative at some point. So this is what happens because the oil market, it's very, very sensitive, supply and demand. You have an oversupply by 1%, the price crashes. The other way, the price soars. So it's a very tricky beast. And of course, it's absolutely critical to countries that get most of their GDP from selling oil. So basically, this is how much money a barrel of oil needs to sell for these countries to basically meet their national budget, to pay for everything that they need to do. And so you can see when the oil price was below, say, $50 a barrel, then it really does put these economies in a difficult situation. Well, now the oil price has rocketed back up to $95 a barrel because of this economic rebound as economies are on the up post the COVID situation. Then, of course, selling oil becomes a much more profitable thing for these countries to do, and indeed to pay for everything else that they need to. Now, okay, what's going to happen from now on? Well, this is from the International Energy Agency. And there are very, very many predictions for how the oil supply, how demand is going to play out, the whole lot. But they offered, this was during 2020, two possibilities. The stated policy scenario, well, you can see expected recovery in demand up to 104 million barrels a day by 2040. And assuming that the recovery was going to be a bit slower than that, only up to 100 million barrels a day. But I can say that demand has rebounded to above 100 million barrels a day already. So there's no sign that of peak oil demand. This is talked about. But as things look at the moment, it would appear that oil is going to be something people want for quite some while. interesting situation from the carbon emissions and climate change point of view, but this is the way the market forces are looking. And these predictions assume that there'll be an increase in upstream investment from now onwards, and a barrel of oil has to sell for $75. Well, it's up at more than that now, so if it stays that way, then this is going to be no problem. One potential problem, though, is that US shale-like tight oil is a major component of the overall oil supply. And yet, if you look at this, ever since the last 10 years, the shale industry's been losing money. They don't really make money out of selling oil. The industry keeps going on, money pouring in from investors, and the fact they could borrow money at very, very low prices. But I don't, maybe even zero interest rates, but I don't see how an industry in this situation can really keep going forever. And as I said before, if the shale industry were to fall in its production output, because we've become so dependent on it to grow the oil supply overall, then this is going to put us into a very difficult situation. And so the changing climate of the title, you might call these the world's woes. There are all sorts of things we're familiar with. Oh, carbon emissions, climate change, well, that's a real biggie. Population, declining resources of all kinds, even fish, land degradation, loss of biodiversity, the whole lot. The thing is, we often look at these things as though they're individual problems in their own right, but they're all interconnected. They're symptoms of a single systemic problem, the fact that we're over-consuming limited resources, and not only that, but we're over-consuming them so the waste from our use of them is exceeding the assimilative capacity of the planet to absorb the waste that we produce. So this is an overshoot situation. I'm indebted to Professor William Rees for this slide. And really what this is trying to point out is, okay, the carrying capacity of the Earth, the biocapacity, that's the dotted black line running along the center of the chart. But the point is, we are above that. We're an overshoot. That's the red line, the solid red line. If we carry on this way, well, as long as you carry on in overshoot, you are degrading the carrying capacity of what you have to depend upon. And then at some point, the system is likely to collapse. So what we've got to do is to get to one planet living. We've got to change our use of resources so we actually stay within the capacity, the biocapacity of the Earth to produce the resources that we take from it, but also not to exceed its assimilative capacity, which we're doing on a grand scale in terms of our waste in all forms. And so signs of overshoot. Well, I've put the first 5 in italics. Okay, for sure. Increasing atmospheric CO2 concentrations, so clearly they're above the assimilative capacity of the Earth to absorb carbon dioxide. That's leading to global heating. CO2 is acidifying the oceans. The heating effect, 90% of the additional heat's gone into the oceans. So you can expect that to really heat the atmosphere and so on. So we can expect melting ice sheets, glaciers, sea ice to continue for many years to come, even if we could stop emitting CO2 right now, which we can't. These ice melts contribute to rising sea levels, but also the heating of the seawater, the oceans themselves, that obviously expands their volumes. It looks like we're going to lose a lot of the corals, which is absolutely terrible because 1/4 of all marine life depends on them. But we're also overfishing, we're decimating fisheries, we're erasing the forest. A lot of tropical forests are becoming carbon sources rather than carbon sinks. Habitat loss, draining fossil aquifers, so on and so on, soil erosion, massive species extermination, the insects are dying off. Pollution, we've heard a lot about microplastics and plastic pollution generally, and quite rightly, but chemical pollution of other kinds has continued. And forever chemicals, these are polyfluorinated alkyl substances. and they hang around for a long, long time, even longer than plastics do. But of course, plastics, as they hang around, they're broken down into smaller and smaller particles. And our total consumption of resources, natural resources, that's to say stuff that grows, stuff that's mined out of the ground, is about 100 billion tons per year, predicted to almost double by 2050. Is that realistic? Well, I would doubt that very much, but that's where we are. But the point I'm making is that obviously we've got to get away from fossil fuels. We've got to move over, we've got to decarbonize the system, move over to a low carbon energy system. But even if we completely change our energy system, if we still continue to consume by that system remaining at the same size, everything we are at the moment, then still we're going to exceed and degrade the Earth's biocapacity, and all these other effects, deforestation and everything else on the slide there. Okay, we get away from the carbon emissions problem, but all this other stuff is going to continue unless we change our relationship with our resources. Now, the situation we're in, the scientists' warnings. Well, 30 years ago now, the first scientist warning came out, and this group of scientists concluded that because of our consumption, humankind was on collision with the biosphere. And then 25 years later, in 2017, some of the original scientists, but some new ones as well, looked at the situation and concluded that apart from the ozone layer, which actually had healed up, everything else had simply got worse. And the first 1992 paper was signed by 1,500 scientists, I think, and it was 1,700. And the 2017 paper's been signed, endorsed by 15,000 rather. So 2019, another paper came out, and this looked at the climate emergency specifically, showing exactly where we are at the moment. And the most recent of this series is the 2021 Scientist Warning into Action paper. And it's that qualifier that sets this scientist warning apart from the others, because this looks at what we need to do and how fast we need to do it, really, to make a difference, to start to putting this degradative process into reverse. And we got this published just in time on the last day of COP26, which we were quite pleased about. I co-wrote the energy section and contributed to the food systems section, but it's a very dense document, a lot of 15 people altogether, but there was a lot of input to this, so coordinating it was quite a task. But here we are, we're an ecological deficit, certainly in the UK, most of the industrialized nations, in terms of the amount of capacity, biocapacity we need to import or liquidate to meet consumption. Well, we're using up more than we have. We're all in the red in terms of consumption against resources. But we're caught between the devil and the deep blue sea, because if we carry on using the amount of energy we are now, and we get it from the fossil fuels, we all cook together in the same planetary pot. But if we start closing down coal-fired power stations and then gas, but we can't install enough renewable energy, because you need a rather delicate matching operation to happen. You close down one, you introduce the low carbon equivalents, then there is a danger of holes emerging in the energy supply. And to put this into context, to cut our CO2 emissions by the desired 45% by 2030, we need to do an awful lot by 2030 to get ourselves on the correct trajectory to hit net zero by 2050. We need to add 1.2 times the current total global wind plus solar that exists on Earth each year for the next 8 years. Now that's quite challenging. I mean, if you look at it, 2020 was a record year for the installation of new wind plus solar, mainly solar. But although it was amazing, something like 25% additional solar, 15% new wind energy. That's starting from a fairly low level. And so that just adds up. The total amount of wind plus solar is just less than 4% of total primary energy. So there's a long way to go. So really, if we're going to do this, we need to expand that record 2020 rolling out of more wind plus solar tenfold. So we've got really quite a task on our hands. So if we're going to try and maintain the amount of energy use at current levels, and we can't start to make appropriate substitutions fast enough, well, we will end up carrying on burning fossil fuels and emitting CO2. Or the alternative view is maybe along with bringing out more low carbon, that'll be mainly renewable energy, we actually curb our use of energy. We figure out how to use energy more effectively in the process. And if we do that, if we begin to use energy more effectively and curb our overall demand, that does bring the necessary challenge of how much renewables we need to install down to more, I use the word guardedly, manageable levels. I mean, there's no time to waste. It's a huge job on our hands. We've got to decarbonize the energy system, but we do need to look at reducing overall energy and resource use from this point of view, and also from the overshoot point of view in regard to the Earth's biocapacity. Well, how much do we need to reduce consumption by? Well, if you look just to get an idea of that from the ecological footprint analysis, globally, maybe by 40%. But in richer industrialized nations like this, we might need to cut back by 70%, because the richest 10% of the population are producing more than 50% of the total emissions. But of course, this depends on how much wild nature we decide to leave alone to regenerate. The more nature we leave alone to get on and regenerate, well, the more we have to curb our emissions. So a summary of the scientists' warning into action paper. We focused on 6 particular headings, although naturally, these are all completely interrelated, but we looked at energy and we concluded that we need to implement massive conservation practices, really, as I've just been saying, retrofitting buildings, relocalization, buying less unnecessary stuff. And actually, by a combination of such measures in the UK, we could cut our energy demand by 50%. But of course, very definitely, we need to transition away to low carbon sources. Atmospheric pollutants, well, there's a lot of methane that might get released into the atmosphere because of the warming of the Arctic regions. So we need to look at how to curb methane emissions. Mostly that's from agriculture, but also from the oil and gas industry. We need to conserve, restore, and rewild ecosystems like forests, grasslands, peatlands, wetlands, and mangroves, because these have a huge ecological potential for sequestering atmospheric carbon dioxide. Food, a big point here is to shift to a more plant-based diet, away from animal-based foods, adopt more regenerative and local production methods, curb food waste, because we waste about 1/3 at least of food that's grown locally, and also produce more at the local level, so place-based food systems. Well, economic reforms, certainly the growth economy, the neoliberal economy, it's sometimes termed, which works on maximizing GDP growth, to one that actually operates within the limits of the Earth, and work towards regional self-reliance, and that would involve local production more of food and consumer goods as we need them. And we also propose implementing high taxes, imposing these on high carbon luxury goods and activities to try and put a pricing force against the overuse of things we really don't need. The most difficult topic is population stabilization, but the global population is increasing by 200,000 a day. And it's not just the number, of course, because somebody in an industrialized nation like this is probably using 10 or 20 times as much in the way of resources as somebody in a developing country. And so we suggest, I suppose, what you often hear, guaranteeing education for young women and voluntary family planning services. It's a very complex topic, and certainly nobody has an easy answer to that one. So if I could ask you, if you are in accord with most of what we're saying, would you please sign the Scientist Warning into Action paper? We're trying to get 20,000 plus signatures from scientists in all nations of the world in time for COP27 to stimulate action. And a scientist is anyone with a degree in science of any kind, the natural, social, political, physical, health, behavioral, or other sciences, economists, and engineers. That would do very nicely. And you can read the paper from that link there, and I think you might find it interesting. It's a very densely packed document. The two lead authors were Phoebe Barnard and Bill Moomore, and I'm the corresponding author. There were 15 authors altogether, so it was quite a job altogether. Now, I'm not suggesting for a moment that any of this is going to be easy, or whether we might indeed pull it all off. But when I was putting this together, I came across a quote to Buckminster Fuller, who said that we're called to be architects of the future, not its victims. If we do nothing, then it will become a self-fulfilling prophecy. So we need to act now and on a grand scale to have the kind of future that we wish for ourselves and for our children and grandchildren. Okay, well, that's me finished for that. And thank you very much for listening to me.
Thank you so much, Professor Rhodes. I fear that list of actions might be too much for a Wednesday afternoon, but I think we all get your point. But it's also kind of hard for each person to balance individual action with the kind of overwhelming, urgent need for the whole planet. Thank you for the presentation. And we have a few questions, so I'm just going to go directly to them. In your opinion, was COP26 useful in addressing some of the issues that you have highlighted? And if I may add to that, did the COP26, do these COPs, I don't know, do they disappoint you? Does the pace of action is it demoralizing to the scientists who have written this paper?
Yes, it is demoralizing. Certainly some good things came out of COP26, but it doesn't go far enough because it doesn't really address the overshoot problem. But for example, 80 nations signed up to stopping deforestation. Whether that will actually happen or not, but deforestation is an incredibly negative force, not only because you're removing the capacity of the trees, say, you're destroying whole ecosystems, the trees start to go, you get huge releases of carbon dioxide from the soils and so on and so on. But it was good to have that agreement. Also, it's the first time coal was mentioned specifically and directly at a conference, and also a number of countries agreed to curb methane emissions. The thing about methane is it's a much more powerfully warming gas than carbon dioxide, and there could be huge amounts released into the atmosphere. If that happens, then because we're basing most of our thinking in terms of climate change in terms of carbon dioxide release, methane really would be a quite nasty joker in the pack, and that could take the climate into totally new territory, possibly beyond where we could go. So those were very positive. But the other thing is that the way these COP conferences have worked, every 5 years is the review year, the review conference. So the Paris Agreement, that was, well, it was 6 years ago because COP26 was supposed to be last year, but it didn't happen because of the pandemic, so that was postponed. But now COP27 is going to be a review year. Every year we'll review exactly where things are, rather than, well, things can kind of slide, can't they, over a 5-year period. But it's accepted now that the situation is sufficiently severe that we can't waste time. And the paper, the Scientist Warning into Action paper, it does emphasize this and the kind of action that needs to be taken in the next couple of years, and then the next 4, and out to 2030. As I say, we have to do an enormous amount by 2030, because if we don't, we'll miss the boat of getting onto the right trajectory to net zero our emissions by 2050. So I think good things came out of COP26, but it could have gone a lot further.
We have a lot of interesting questions which are very different in scale, which makes them very, I'm curious. Beyond Roberts asks, can converting coal-fired power stations to biomass, perhaps with carbon capture and storage, play a useful part in reducing carbon emissions by 2050, together with other measures, including reduced consumption? And I'm also curious about your take on carbon capture and, about the current projects in the UK, especially Scotland, which seem to be full steam forward. Is that a pipe dream, or can we depend on that? Because there seems to be a lot of hope being placed on one technology, which is risky.
Yeah, it is indeed risky. It's certainly going to be expensive to do. Well, it is, which is why it's probably not happened on the grand scale so far. It also consumes a lot of energy. For example, if you're talking about coal-fired power stations, you practically need, for every 3, you practically need to build a 4th to provide enough energy to basically capture its own CO2 emissions, and those are the other 3. So you are putting a huge additional burden on the energy system if you're going to go down this way. Now, it's very controversial, bioenergy, carbon capture and storage. For one thing, depends on where the biomass is going to come from. If you're going to clear cut forests, well, that has all sorts of terrible negative impacts. So that's not really very helpful at all. I think the better way, certainly, is to look to ways of using the energy we have available to us more effectively and basically curbing demand. I'm not totally sold that carbon CCS is going to happen on a big enough scale anytime soon, if ever. And if you're talking about, as I say, BCCS, then there are potentially very negative environmental impacts. So I don't look at that personally as being a totally positive way forward.
We have a UK specific question. Lewis asks, in an effort to minimize the burning of fossil fuel to generate heat in UK domestic properties, the government has encouraged heat source pumps to replace traditional boilers. These seem to be highly inefficient in the UK and essentially underdeveloped technology. And I'm wondering where Professor Rhodes feels future boilers or heat sources are better fueled with lower impact. Would it be hydrogen?
Yeah, heat pumps, certainly they are more efficient. They need electricity to run them, so the electricity's got to come from some source or another. But you can maybe get 3 or 4 times the heat back from that. Now, if you're making your electricity from renewable energy, well, that's marvelous. If you're burning coal or gas or uranium in a power station, you're already throwing away about 60% of the primary energy in the form of heat. So the overall sum isn't quite so positive with heat pumps running on electricity in that sense. But certainly, as part of a much more renewable energy-based system, then it could be very good indeed. But I come back, we've got 29 million homes, it's reckoned, in the UK. So installing in time enough heat pumps is going to really be quite a challenge. And the government targets so far are nowhere near enough for this. And this is also true of retrofitting buildings to thermally insulate them and draft insulate them. So if we're going to go down that line for the UK, there's an awful lot of work to be done. Really, it needs to be scaled up rapidly. So in principle, yes, there are advantages. For sure, if the electricity is going to come from renewable sources, say, but within the present system, there are the limitations of how we make our electricity. And we've closed down most of the coal-fired stations. There's only about 2 left. We still make about 40% of our electricity from burning gas. Now, we're doing much better in terms of renewables than the global average, but certainly there are challenges, and there's a long way to go if we're going to get everything done that we need to by 2030 to get on the right course for 2050. We've got to try and make sure we don't miss the boat. That's why very rapid and large scale action is necessary. And now there's no time for shilly-shallying, basically.
Yeah, I think that time has passed.
Mm-hmm.
We put a couple of questions together which are kind of similar to each other. Gail's asked, what's stopping people and organizations from taking action now? I guess it's kind of a behavioral question. Do people tend to think that it's someone else's problem? And Simon Piggott has asked, do you see grassroots movement as critical to supporting these actions that are required, or does the focus need to be at the governmental level, or perhaps they just need to channel into each other? What would be your thoughts on that?
Grassroots movements. Yeah, I mean, I'm involved with the Transition Towns movement, for example. There are various ideologies like this. But yes, I think these are mainly driven by a lack of faith that the government is going to solve all our problems for us. And maybe they will, but the point is, the more you can do at the local level, the more you can do at the community level, the more you can produce in terms of your food, for example, because we've got this just-in-time system, which is really very, very vulnerable. We've seen supply chain problems as a result of the pandemic, and also Brexit hasn't helped exactly. But the more we can produce, as I say, energy, food, and really what we need at the local level, then it does give us a kind of resilience to some degree. It also begins to help to build communities or strengthen, because I think in the time we're coming to, we really are going to need everybody getting together to support one another in these endeavors. So I've probably forgotten what the first 2 questions were, but that's my overall view, that we can see the government is certainly talking about retrofitting buildings. They've got their sort of green policy and so on, and there's some very good ideas in that. But 29 million homes, it's going to take more than 10 years at the government's proposed insulation rate to actually do the job. But yeah, indeed, I think these are problems that need to be addressed and squeezed on all levels. And that also is something that we point out in the SWIA paper. We try and look at levels of scale as well as time scales. It's a work in progress. I mean, this is a complex matter, but yeah, I think it's going to take a push from all sides, because it is a systemic problem in a literal kind of way. There's no one solution. We have to do a lot of different things to try and tune the system so that it works more effectively and within the available resources, including our economic system. And that is going to be quite a challenge to change that.
All right, I'm just going to ask 2 more questions. They keep coming in, so I guess I'll have to draw the line at some point. What is your take on EU approval of nuclear energy as a solution for replacing fossil fuel use? Or are there any confounding factors or other things that we need to be careful about if we rely on nuclear?
Nuclear energy, of course, has the nuclear waste problems that we're all familiar with. The thing is, if we were going to seriously expand our nuclear program, including these, not just the small modular reactors, which are only up to about a third of the size of a standard one, but the micro reactors, so you can have one producing electricity for, I don't know, a few hundred homes or something in principle, you're going to need to find more fuel, more uranium fuel, if you're going to use fission reactors. And so looking in general, it's reckoned there's about 130 years worth of uranium fuel. Sure, there's loads of uranium, poor quality uranium, that will take a lot more energy to recover. So not that, but as things stand. So if you seriously expand the amount of nuclear you need, then you just get through that fuel much faster. And if you're going to do that and leave a lot of nuclear waste in the process, then is that really the best way? The other way, where you could really eke out the uranium fuel, is to go over to, if you like, call them fast breeder reactor technology, where you would use most of the uranium, but of course you've got to convert it into plutonium. And that has obviously all kinds of undesirable features. So I would tend to say, yes, there are certainly problems with renewable energy in terms of the resources we need to get that together. Without nuclear, then we're going to have to roll out even more renewable energy. We need to also roll out enough battery capacity. Certainly if we get to a level of market penetration of renewables that we don't have the gas station backup, then really we are going to have to even out the intermittency aspect. So this complicates the whole problem. But as I say, if we can reconfigure things, reconfigure towns and cities so we can do things more locally, if we can insulate buildings and so on to cut our energy use, then it makes the task that much more manageable in terms of how much fossil fuel free energy we need to put together in the future, whatever that source might be of low carbon energy.
Right, I'm going to make this the last question because I think it involves all of us. Are there any best practices for making the case for reduced consumption? And I guess we all struggle with this from time to time.
Yeah, it's a problem, isn't it? That we've got as a consumer society, we've got advertising, we have really the way that most of us are brought up is in a culture of having more. And I think the majority of people don't want to give up or cut down on their holidays, don't want to give up their car, because it looks like a retrogressive step. You feel that somehow you are losing out. And yet what we will lose if we try and continue along this line is far more. So there needs to be a big, you could say, educational program. But the message of consumerism or deconsumerism needs to be made emphatically to try and change people's behavior. And really this has to start from, well, the time when we're very young, because otherwise I don't think it's going to catch on and be very popular. Also, any politician who stood up and said, do you know what, you've got to have less, they're probably not going to get elected. So I think there is a set of problematic elements here. We have to do it, but it's got to be made more attractive somehow. There's no point frightening people to death. There's no point scaring people away, because if you do that, then, well, same for all of us. We have a tendency to do nothing and carry on in the same way. So ideas like what you can do at the local community level and so on need to be presented actually for the good things they really could be, rather than the immediate perception, which would be doing with less, missing out, and so on, because it really runs culture to the message of the consumer culture in which we find ourselves.
Yeah, you're absolutely right that it has to start in the childhood, because, you know, with current cultural messaging, like you only live once, missing out on everything, which all means that grab everything right now. But fortunately, we do seem to have a lot of very enthusiastic and passionate young climate crusaders who are definitely disseminating this exact message, is that you can do with much less.
Well, it's their future. It's their future more than ours.
It's true. Thank you so much, Professor Rhodes. This was really wonderful, and I'm so delighted to have invited you for this talk.